Hello, this is El Diablo Uncle Johnny. This is probably one of the very first videos that I am making that is what I really intended to do when I started my YouTube channel, was to teach mechanical knowledge and theory. I went to vocational school 3 years in Cleveland, Ohio, and I'd done mechanic work for years before I started driving truck, and I lost my CDLs after a mishap with a law change that I didn't know about after a flood. But the purpose of today's video is to discuss and talk about the original GM diesel, or what was traditionally called the Jimmy diesel, or which became the Detroit diesel also, the two-cycle Detroits. There are thousands of people on YouTube which condemn these engines as sick dogs that leak oil, make a lot of noise, and have no pulling power. So the purpose of the video is to explain to you a little brief history of the Detroit diesel. It is not a truck engine. The original two-cycle Detroits, what I call a Detroit, the Jimmys, were boat engines. They were designed by General Motors as a safe, efficient, potentially reversible, fully mechanical, simple, powerful within reason power plant for boats, particularly landing craft in World War II Higgins boats. Diesel fuel was much more thermally stable than gasoline, and the fuel economy was much better, and they did much better. You didn't have a spark plug, you didn't have magnetos and a coil and a distributor. So it was the most desirable type of power plant for a boat, particularly open type landing craft or Higgins boats. And the Detroit, or General Motors, won the contract to make these for the military, for the Department of Defense. At the end of World War II, there were thousands of these motors, and people started putting them in trucks. And immediately they started complaining, well, they're noisy, and they leak oil, and they don't have no power. And what they're referring to is pulling power, or you get a big load on a hill, and will it pull down to 16 and just keep chugging? No, it was never designed for that. It's like putting a two-cycle or a two-cylinder Briggs & Stratton 32 horsepower motor, in a locomotive. It won't do it. It was never designed for it. The Detroits were designed for boat service, and they do great for that. They're reliable. They're EMP proof. There's no computer. They're simple. They're very rudimentary. There's nothing high-tech about them. And because of the prop in the water, they were not locked mechanically without any source of slippage, and so they did a fine job. That's what they were designed for, and that's what their primary intended purpose was. People started putting them in trucks and found out immediately that when you have mechanical links that don't absorb impact and shock and torsion or torque, the bolts work loose, and people would complain about that. And as that happens, it tears the gaskets and they start leaking. And drivers would always run them wide open to try and get power out of them, and so they would naturally, wear out, and the seals would be destroyed, and the supercharger would start passing oil. It's because you were using the engine for what it was never designed for. Now, Detroit made several improvements to the engine to keep from losing their reputation by the trucking industry and the truck market for complaints about the two-cycle Jimmys, the Detroits. And they did make a lot of improvements, and they did make progress. That was all killed when the Detroit could not meet emissions requirements for the growing and more powerful EPA, which pretty much killed the Detroit diesel Allison, the original two cycles. And that's why they sold it, and it became the 60 series. Still the same name, but it's not the same design. It's not the same company. The original two cycles, they do great. Detroit found, we put them in buses, they do great because it's in front of a torque converter, an automatic transmission. And they did great in construction equipment, which had hydraulic pumps, and you have a pressure regulator and a bypass valve. And they do fine for that. And there are still thousands of them, and there's still thousands of them in buses, and they still do very good. There are certain things of the Detroit diesel that most people do not understand, so I made this video to inform you of them. Detroits have 2 power strokes for every 2 revolutions, where a traditional 4-cycle diesel engine or gas engine has 1 power stroke for every 2 revolutions. So when you take its cubic inch displacement, you multiply that by 2. And so the exhaust requirements and the intake air requirements of a Detroit is a little more than twice that for a 4-cycle engine. And if you can't supply that, you choke the engine off and you choke off the exhaust. And until you get the exhaust out, you can't get the air in. And so you can't burn the fuel efficiently. And this causes a lot of power problems. So people, to solve that, would run a very large single or dual air cleaner, and that wasn't a major problem. But their big problem was in the exhaust. So they would put a large single or dual exhaust with straight pipes on it so the engine could breathe. The problem with that is because there's 2 power cycles for every 2 revolutions, you have twice the exhaust pulses. And if you can't slow that gas down and dampen it out, you don't get steady exhaust flow, which is quiet. You get a very loud pulsing. This is what causes Detroits to be very loud. They can be quieted down. But in most applications, in trucks and in buses, you can't adequately exhaust the engine. And so they would run straight turbo type mufflers, which is basically like a thrush or a glass pack. And they're very loud, and people complained about them. They hate them. You could hear them coming a mile away. And in a truck where there's no automatic, all the pulling and then the jaking, the engine twists and warps, and it works the bolts loose. This tears the gaskets up. And then mechanics, if you could call them that, they take the engine apart and they use pry bars and punches and they mar up the sealing surfaces, which chew up and eat the new gaskets when they rebuild it, and so they leak. When you use the engine for what it was designed for, they do a good job. They are a polluting engine. They made lots of different types of injectors for Detroits. They made a low popping pressure and a high popping pressure. The low popping pressure was right around 600 psi before it would pop the valve in the tip of the injector and inject the fuel through the nozzle tip. The high pressure injectors were around 1200 psi. And they break the fuel into a much finer mist, which burns more efficiently, makes more power. It takes less heat to vaporize, and it takes less advance to get the fuel to burn before the exhaust valves open. Detroits were never designed for trucks. You have a 5-inch stroke, and you lose about an inch of that, a little more, on your ports. And the exhaust valves open about 20 degrees before the piston, in its crankshaft revolution, gets to uncovers the ports to let air in through the blower box. So you're losing at least a third of the stroke when the pressure could be pushing on the piston to develop horsepower and torque. And so that is an inherent drawback to the 2-cycle design. Now, because of the moderate RPM in a boat or something with a torque converter where there's fluid slippage, where the engine can stay revved up without being mechanically killed out, Detroits do fine for that. That's what they were intended for. That's what they were designed to deal with. And they do fine for that. So when you complain about Detroits not having pulling power in trucks, that's why. I just explained it to you. Nobody else that I've ever seen on a YouTube video has explained it properly, but I just did. They lack the intake and exhaust. You have to have some type of cushion like a torque converter or a prop. They were intended for that, not for trucks. But people used them. Well, to keep from getting their reputation dragged down, Detroit kept making improvements so that the engine would be more tractable, more appealing to the trucking industry. And they had probably 20 to 30, maybe even 40% of the trucking industry. They had almost all the boats, the generators, portable air compressors, construction equipment, public transportation, school buses, Greyhound, Trailways. They were all Detroit powered. And they had a tremendous share of the diesel engine sales market. And this was the livelihood and the bread and butter for Cummins engines and for Caterpillar engines. So to compete against that, Cummins and Cat come out with V8 higher speed, shorter stroke engines. Cat made a very good one in the 3208. It evolved over time from a flat tappet cam, naturally aspirated, to a roller cam with a turbo. And they eventually got them up to about 425 horsepower. And they'll run 2,800 RPM. You can run them all day at 2,500 RPM if you've rebuilt them and set them up and blueprinted them, balanced them right. In front of a torque converter, they do a great job. They're great in a bus. They're great in a boat. They're great in construction equipment. And Cat did get a certain part of that market back from Detroit. Cummins come out with the triple nickel, which was underpowered because it was a small engine. It was 555 cubic inches. They actually had a 478 before then, which had a shorter stroke. When that wouldn't fit the bill, they put a turbo on it, and then they finally went to the 903. People put those in trucks and complain, man, they sound great. They sound really powerful, but they're sicker than a dog. Well, they are, until Cummins flowed out the injectors, put in an aftermarket cam and a blower and a turbo. And the Army still uses those in the Bradley fighting vehicle. They get 650 horsepower out of them. If you detune it to around 450 in front of a torque converter or in a boat or in something where it has slippage built into it, it's a good engine. They were designed by Cummins and by Cat to compete for the markets that Detroit had locked up with their V8 designs, the 318, the 350, and the 92 series. So when you complain about Detroits and these certain Cumminses and 3208s, Cummins got some of the bus market, and they got quite a bit of the boat market, and some portable generators and stuff like that. And Cat did good with like garbage trucks and some school buses and a few public transportation buses and some construction equipment. These were markets that they thought they had locked up, and Detroit took a lot of that away from them with the two-cycle V8. And so to compete and get part of their market back, that's why Cummins come out with the triple nickel and the 903 and Cat the 3208. They were never intended to be put in trucks with manual transmissions. They're higher speed motors because they're shorter stroke. And they'll, the 3208 will run all day at 2,300 RPM. That's pushing it on a Detroit. If you took, say, an 855, a Big Cam 3 or Big Cam 4,400, or a 4 1/4 Cat, a 3406B, and you spun at 2,300 RPM, it fly apart. They're not designed to be spun over 2,100. The V8 engines have 5 main bearings, where a straight 6 has 7. You need to understand that. Straight 6, 671 Detroits, the straight 6, has more main bearings, and the rods are wider, so there's less pounds per square inch of loading on bearings. So when you complain about engines, you need to understand and know engines, and since we're talking about Detroits, this is what you need to understand. If you rebuild them right, they do a fine job. Detroit finally come out with the 92 series because of the trucking industry was complaining, well, Cummins is doing pretty good and Cat's got the 1693, we need some more power. Detroit come out with the 92 series, and they immediately made an improvement to it called the bypass blower. Your blower, or Roots type supercharger, consumes up to 30 horsepower. So Detroit come out with a bypass blower, and at a certain pressure it will overcome the spring and go completely past it, and does a fine job. It does much better than the blower and consumes very little horsepower, if any, whereas the blower consumes a lot of power. They made different size blowers, and they made different ratio drive systems. 20% overdrive over crankshaft RPM, 35%. Once you bypass that, the load on the blower is much less, so there's less of a chance of snapping the blower drive shaft, which already has to run the governor, and it also has to run the fuel pump. And so this consumes a lot of power. When you bypass the blower, you negate all that. That was a big improvement. And as far as I know, they made a few blowers that were bypass type to put on 71 series because they were very successful. And it was a very good design and a very good improvement for the two-cycle Detroits. The first original ones didn't have that. The blower, or turbocharger, does not mechanically driven by the engine. And so at idle, it would never make enough boost and pressure to flush out the exhaust gases and run the motor. So they had to keep the blower. But the bypass blower setup was a very good improvement. What you need to understand is that Cat and Cummins did what they did to get part of the market back, which Detroit had locked up. They were losing it. Plus, they were losing a lot of sales in the truck market. And they're like, man, they're taking a lot of our business away. We got to get some of it back. And that's why CAT come out with the V8, the 3208, and Cummins, the triple nickel, and the 903. Now, I'll make more videos about this. I don't have a high-tech setup with lots of equipment and stuff, so I can't show you parts, but I can explain it. The two-cycle Detroits were very innovative and novel for their time. There was a rifle-drilled passage in the connecting rod which carried engine oil up around the wrist pin and squirted it to the underside of the piston to cool it, whereas other engines had piston cooling jets that had to be bolted, and they could be bent and misaligned, and that caused a lot of trouble. You didn't have that problem with the Detroit, and so Detroits were very innovative with that. Detroits had roller lifters, which consume much less horsepower to rotate and operate than a flat tappet mushroom can. And now they all have roller lifters. Detroit was doing it long before them. So the Detroit, when they put them in construction equipment and some other applications, they had what they called a redesigned governor housing, which was a load compensating governor. It had an assist spring with an over center bracket on it. The first traditional ones, and most of them, the governor controls idle speed and your top end from about 18 to 2100 RPM or whatever it's set at. But the rest of the RPM range is controlled by the driver's foot. There's very little or if any governor compensation. At 1100 to 1200 RPM, the idle spring plunger will contact the barrel assembly, and there's like a 1/1000 inch gap on it. At that point, when you continue to push on the fuel pedal, this is not a gas pedal, it's a diesel engine, the fuel pedal, it's all under the driver's control. The governor doesn't compensate, whereas Cummins PT pump does, and the CAT in multiple plunger injection pump does. Now, even without a governor assembly in the Cummins PT pump, physics would give, because you slow the engine down, there's more time for the fuel pressure to get fuel through the little metering passage into it. So simply by design, the Cummins pump will compensate for load, but there's also a governor that helps do that. But the Detroits did not have that until they come out with a load compensating governor. And so if you complain about, man, you got to run it wide open to keep the power up, well, that's why. Because whenever you would hit a hill at, say, 1500 RPM, and the engine would start dropping off, the governor didn't move the rack any. It was past the idle limit, and it didn't achieve or get close to the top end RPM limiting limit. So it was all driver control. So there's very little fuel compensation other than the driver's foot or a hand throttle, depending on what the application was. So you need to understand some of this stuff when you start condemning the old Detroits and say, man, they were noisy. I've drove some old Freightliner cabovers back in the 70s after I got out of vocational school that had dual mufflers with a spinner muffler off of the turbos, 350 Detroit. They were pretty quiet. Much quieter than these ones you hear running up and down the road with a straight exhaust that just sound like they're screaming demons. Your gas engine would make just as much noise if you run a straight pipe. You'd get pulled over and get a ticket. It's called noise pollution. You know, most communities don't like that. The bottom line is, this video is getting way too long. I'll have to make more of them. But I wanted to talk to you about the Detroits and explain to you what their purpose and intention was, and what their shortfalls and pitfalls are, so that you would know more about them. And I'll teach you much more in my videos to come. This is what I originally intended my YouTube channel to be. It kind of got off on a tangent, but I'm going to do things a little different this time. I'm getting older. There are not a lot of old school mechanics left, and so I want to pass this on to people because it's very important knowledge. These engines are EMP proof. Foreign governments buy them up like crazy because if there's an EMP event or attack from like a solar flare, these old diesels will still run, and they kept our country running for years, and they'll do the same for other countries. So they're very desirable. So don't think they're junk and they're old dinosaurs. They're very innovative, and even, they're still respectable even by today's standards. I have to say goodbye now because this is getting a very long video, but we'll see you soon. Have a nice day.